Okay, so now we are going to talk about logs. And logs, we're not talking about pieces of wood in a forest. We're talking about numbers with a very special property. So we've already talked about exponential equations, exponential functions, and we're going to see the connection between logs with those right now. We know here we start with these three exponential equations, and two of them we can solve right away. We know 2 squared is 4, and 2 cubed is 8. And with 5, we don't think of 5 as a power of 2, right? But it turns out that it can be written as a power of 2 as long as we allow x to be a number that's different from it's not an integer or a whole number or even a fraction. And we know we should have this should have a solution, because if we look at the graph of y equals 2 to the x, we know it's a nice smooth continuous curve, right? And if we go to the 5, that corresponds to a point right here. And there is a point on this graph where the y-coordinate is 5. That y-coordinate is going to have an x, or that point is also going to have an x-coordinate. And we can see that x-coordinate lies between 2 and 3, but we can't really see too much what that actually is. But there's some value x for which this equation is true. And so we see intuitively that this should have a solution. And we're going to see that this is going to be an example. This x-coordinate is going to be an example of a log, and we're going to see that this is a number that we denote this way as 2 log 2 5. And we'll see what this actually is. So let me just say that there are some numbers that are defined by the equations they solve, or the geometric quantities they represent. That's how they're defined, rather than any particular numerical or decimal approximation. We all know that pi is the value of the circumference of a circle divided by the diameter of the circle. Okay, that's how we define pi. 1/7, well, we can think of it as a fraction, but it's also the solution to this equation, 7x plus 1, right? Square root of 3. Now this is going to, we don't really memorize its decimal approximation either, but we know it's the number you get when it's the number that if you square it, you get 3. So it's a solution to x squared minus 3. And so the log base 2 of 5 is we just call this is define it to be the solution of 2 to the x equals 5. It's the number that you've raised 2 to it, raised 2 to whatever the number is, you get 5. That's by definition, that's what a log is. So the general idea is that if a is any number, of any positive number not equal to 1, we can define the logarithm of x base a to be the solution of a to the y equals x. Okay, and the way you can think of this is that this is a logarithmic statement, this is an exponential statement, and every exponential statement has a corresponding logarithmic statement, and vice versa. The way I remember this is that a log, in fact, is a log. It's an exponent, but if you raise a to it, you get x. Okay. Other way you can look at this is if you have something in exponential form, where y is the exponent, we say y is the number that if you raise a to y, you get x. Okay, so this is equivalent. And in general, if you can take any positive number m. Okay, there will be a point on the graph of y equals a to the x where the y-coordinate is m, and then the x-coordinate is going to be this number log base a of m, or the log of m base a. Okay, obviously we need m to be a positive number. M cannot be 0, and because this graph never crosses the x-axis, so there's no, we can't take the log of any negative number or 0. So as some examples, we look at this. When we ask you to evaluate a log without a calculator, we're really just asking you to solve an exponential equation. And the way you can do this is you can well, in this first example, you ask yourself, 2 to the what is equal to 8? Well, obviously this is 3, right? So since 2 to the third equals 8, we have the log base 2 of 8. The log of 8 base 2 is 3. Okay, and we're using this, right? 2 to the 3 is equal to 8. Therefore, 3 is the log base 2 of 8. Using this model up here. 3 to what power is 1/3? Well, 3 to the minus 1 is 1/3. Okay, so that means that the log of 1/3 base 3 is -1. The log of, well, 5 to what power is 1? Well, we know 5 to the 0 is 1, so the log of 1 base 5 is 0. And in fact, the log of 1 in any base is also going to be 0. Square root of 8 is 8 to the 1/2. So this is going to be 1/2. 7 raised to the minus 2 is 1 over 49. So this is -2. You have to think about this. 4 raised to what power is equal to 8? Well, you can think we can do is if we solve this as 4 to the x equals 8. This is the same thing as 2 to the 2x equals 2 to the third power. And then we can set 2x equal to 3. And so x will be 3/2. Okay, so this is going to be 3/2. And you can check that 4 to the 3/2 is the easiest way to do this is the square root of 4 raised to the third power, which is 8. So it works. What's the log of 6 base 6? Well, it's going to be 1, since 6 to the 1 is equal to 6. And this is almost so easy it's hard. 17 to what power is equal to 17 to the 5th? Obviously, it has to be 5, right? Okay. So in a way, these 17s cancel out. Whatever these, as long as these two numbers are the same, they'll cancel out.